Please welcome Mr. Helmut and
That's actually my nickname. So that's yeah, so you can find me on several social media platforms with my nick Helmut. And I also registered the domain. So yeah, welcome. I'm very glad to be here and to be invited to join this great conference and to meet so many new and great people and to visit the first time in this country. What I want to talk about today is not so much going into deep theory, how you should really do things to be completely secure, but to present how it actually can happen to everybody, basically everybody, that a website which you made actually got hacked. So how does it work? How does it look like? How would a diary of such a hack would look like if you just write down everything? So how does it start? It always starts that a client approaches you and says, okay, I want to have a new feature on my website, or I want to have a website at all, and you're going to implement that feature, right? So in this case, for this example, I would say the customer approaches you and says, okay, I want to have a special menu for my page where users can select the content they would like to see, right? So you remember the type-free backend, there are columns in there maybe, and this customer wants to see the content from different columns by having a URL parameter, right? So this is an example type of script I'm writing. I have a content element or content C object I use, and I implement this feature. I say call pos. Please get the call pos from GP, means get post parameter, and yeah, so this should work out, right? And the customer also demands that basically a similar feature where people should be able to search for content. And since I'm a TypoScript guy, I think, okay, I can implement TypoScript, basically the same. I have a content C object, content, and I write the query like that. I search in the header if a search parameter is provided. So how does it look like? Let's test. I implemented it. It basically, if I go to this example page here, I have some content elements here. I have a normal column, I have a right column, and I have a left column, right? And I think it's the default, so normal column is called pos 0, right column is called pos 2, left column is called pos 1. And if I watch this page here on the front end, the default is that I see the normal column, so which is called pos 0, right? So there you can see no difference. But if I say call pos 2 here in the URL, make it bigger for you. So if I say call pos 2 in the URL, then I see the content of the right column. Okay, so far so clear. Everything's great. Oops. Let's see if my search feature works. Okay. So I have these two content elements, and if I search for example, special, oh, okay, great, it works. Awesome. Yeah, example, just to be really sure. Yeah, it works. Okay, so I can deploy it. I think that's enough testing for now. and I give it to my customer, right? And only a few moments later, my customer calls me back and says, oh, okay, I tried your feature, but I think you didn't test it enough. There's some kind of error in there. If I type in the URL and search for something like quote example, then I have a blank page. It's really strange. I think maybe on my development system there's something wrong. Maybe I should really test it on the customer side, right? So because, yeah, I need to test it. And where we test this, of course, I have to test it in production, right? And to really be able to test it, because I have this white page just seeing, I have to enable some debugging features, right? So it's really easy with T3 to enable these debugging features. I just need to go to the install tool. Log in there. Go to configuration, presets, and have my debug settings here. Turn on the debugging mode. Alright, so what is going on here? Let's try again. Ah, okay. That's better. That helped. I get some strange error message here. It says something about database connection, a query. What could it be? So obviously it's some kind of SQL error or something like that. Okay. So I enabled the debugging features, and maybe there's some kind of permission problems, right? So maybe the database user or stuff like that has not enough permissions. So just to make sure that it's not a permission problem, I maybe try with the root user, right? That's hopefully a good idea or whatever. So I try with, I just try that. So here I have the database set up. This is my local configuration file, and I try with the root user, which has a different password. There's a secure one. All right. So I test again. Okay, so maybe it's not a permission problem, right? Okay, so what can I do now? I'm not sure. And what sometimes happens if you're doing something like this, so you're in the middle of a debugging session and you probably enabled the debugging on the live side, and you probably did some stuff there, like I did here as well, using the root user or whatever. It often happens that you get distracted. So you have an emergency call from another customer, you have a strong urge to drink coffee or whatever, you get distracted, right? So it's like, squirrel, oh, there's a squirrel probably somewhere. So you're looking for the squirrel and finding that, and then you probably forget about where you left off the original challenge or the original work. And what then happens is you forget that you left, in this example, the live site in the debugging state, so debugging settings you have enabled, and of course the root user set for the database connection. If that is the case, it may be that other people get attracted to your site. And how can this happen? How can other people be attracted to your site? Because there's an error, right? So it is very easy to find errors like that I showed you before, with a simple Google search. So you can see here, this is an error message or a debugging message from a failing SQL query. And if you actually try this search, this Google search, searching for XX select query, you have an error in the SQL syntax. You find a lot of type 3 sites, type 3 pages, which actually have this result presented to you. So people who want to get some benefits out of foreign websites by, I don't know, implementing some links to pharmaceutical products on your website or stuff like that, could be just using a simple Google search to find pages where they have an easy target, where they can attack in an easy way. So this is called Google hacking, which doesn't mean that these people are going to hack Google, but use Google to find pages which are a good target to be hacked. And if somebody sees your website and sees, okay, there might be a problem there, it might be a good target to attack, they start to trying to exploit something. Exploiting means they're searching for a vulnerability on your page, and they try to use this vulnerability to their benefit. What I'm going to show you now, just a short disclaimer, is okay for education purposes. So I presented here that you learned something, but it doesn't mean that you're going to use these tools now or after that to try to hack customer sites or foreign sites or whatever, because at least I'm not sure how it's in Cambodia, but in Germany it's even forbidden to use these tools for other purposes than education. So if you're going to use them, ask the people or ask the website owners you're going to try to hack. Yeah, so basically don't do this at home. And one tool which is very cool, which you can use to find so-called SQL injections, is the tool SQL Map. Who have heard of this tool before? Okay, great. So it's a command line tool, so you will see a couple of command line things I'm doing right now. Don't execute it here. So this is the command line tool SQL I installed it before. And what this command line tool only needs is a URL to the web page it tries to attack. In this case, it's my local development system here. And optionally provided with one get parameter which it tries to exploit. Right? So I say here, okay, please test this URL, insecurity corpus 0, and try to find some vulnerabilities in this get parameter. So if we go back here, it's basically the state, right? And it tries to provide some different values here to find if there's a vulnerability. Okay, then I can just fire it off. And it does some magic things. Basically, it does a lot of GET requests right now, filling the call post parameter with different things, and trying with these different things if there's some kind of way to exploit. And it takes a little bit, but not too long, and it's fully automatic, as you saw. And it can happen that this is the result of the command. That SQL Map says get parameter call post is vulnerable. And if you get something like this as a result of your SQL command, it means it is 100%. It is 100% sure that you have a big problem on your website and you need to fix it. But if it doesn't find anything, it doesn't mean that you don't have a problem. It's just that this tool couldn't find anything. All right, so it asks me if I want to test other exploits. No, I don't want that. So yeah, now I know it's I have a security issue here. As an attacker, that's really good news for me. Now I think I can use other advanced features of this tool. So for example, what can it offer to me? Let's look. Oh, this option here looks interesting. It says OS CMD, and obviously this tool somehow can help me to execute operating system commands. So wow, how is that? Let's try this out. So what I'm doing right now is, basically I'm using the same command like before. So I'm providing a URL. I'm also saying that it should write a log file. I'll show you that later. And I provide this OS command thing, and I say, okay, please just make a directory listing. Just as a first shot, show me the directory listing. Right, I do so. And what happens now? It's a little bit down. Can you see this from below here? SQL Web tries to do something, but it hasn't enough information. It says, okay, I want to execute the OS command, but before I can do so, please say, is there any scripting language installed on this server? Well, that's a pretty easy question to answer because I know it's a type 3 installation, so there is obviously PHP on there. And I can say, okay, SQL, there is PHP. And I say, okay, PHP. So, next question it asks me, please provide the web server document root. Well,
OSJS. OSJS.
OSJS, thanks. Oh yeah, that's true. Alright. So I obviously want that. And now it asks me, I put it a little bit up here, asks me for the server document root. So, well, yes, okay. I don't know that. How could I know the document root? It's not visible anywhere. So what I would do as an attacker then is try to find out what the document root could be. And I can or could do that by finding other vulnerabilities which expose the document root. So I'm playing around here, say, okay, call boss 2, and I say, maybe call boss 1, what's that? Oh, okay, that looks interesting. Obviously I get an error message here, so there's some kind of error in the application, and previously I, as a web developer, enabled debugging mode. This is why I get this full exception stack trace here. And this full exception spec trace includes some additional information, like here on top. It looks very much like a document root directory. It's also called htdocs for my convenience. So this probably very likely is the document root. And I can now use this for SQL map, right? So what I've shown here is that sometimes it's not enough to have once or to exploit something by finding one single vulnerability, but very often it is the case that attackers need to gather all bits and pieces from different sources. So in this case, I have some SQL injection, but if I want to do more with that, in this example, I have to find a document. So I have this now, and yeah, it asks me if I probably have an alternative. I don't have one. And by doing so, it seems that it succeeded. And it even provides me some useful URLs here where the SQL map uploaded some tools. And asks me in the end if I want to receive the output now. I can say yes. And boom, here I got it. So just from using a tool, I get, in this example, the output of a command, OS system command. What SQL map did, you can see it here already, is using an SQL query to upload two files. Who knew that it is possible to create files on the file system with an SQL query? A few ones at least, yeah, you know. So that's possible, and it is possible because I made a mistake before. I not only enabled the debugging feature, but I also enabled the root user as for my database connection. And writing files is actually only possible if there are certain privileges. And in this case, the root user, of course, has every privilege. And this is why it's possible to write files. All right, so I have a few files here. And since I want to get into this installation, I could probably use these files to get me an additional user in the system. Let's try this. What is actually the command? Let's forget about that. So let's see next. So I try to replicate that again. Okay, so this neat little script here lets me execute commands. So in this case, again, the directory listing. Okay, so if I want to have a new user, how can I add a new admin user to type 3? If I log myself out, for example, I must go to the install tool, right? So just logging out. The attacker probably also knows step 3 and knows that there's an install tool. Of course, by default, the install tool is locked. So what an attacker could do then is just unlock it, because for unlocking, you have to write a file in the file system. But I, as an attacker, can execute system commands. So I can just execute the command to create that file for me. So let's say touch enable install tool. Okay, so I have the install tool open. That's great. Now I need a password. Well, how can the password be? I don't know. Let's try something. Okay, that's very inefficient. That doesn't work. But where's the password stored for the install tool? Who knows that? Besides Mattes. The password for the install tool, where is it? In the local configuration, exactly. So, as said before, I have here system commands. Let's look for a password and T3CONF local HP. Is that something for me?
The too many S's. Password.
Oh, too many S's, right. Thanks. Okay, I have now the database password, and I have some configuration about the install tool password actually is password with an uppercase P. Okay, so now I have a password. Great. Let's try this password here. Okay. Does it work? Why doesn't it work? Of course, it doesn't work because this isn't actually the password, but is a so-called hash of the password. And it's not only a simple hash, like it was before 6.2, I think. It's a so-called salted hash, so it's more secure, so that I can't use this hash value on some website and say, okay, please, internet, the big internet, do you know the real password for this hash? So I have to calculate it myself. But there are tools for that as well. They are so-called password cracking tools. And one of them is a tool called John the Ripper. I can just show you. And it's also a command line tool. It's called John. And I have to provide John with a password file. Since I don't have a file, I just create one. Let's say echo password files are in the format that it first starts with the username and then a colon and then the password hash. And just create this file here, call it pw, and then I say John. Please crack all passwords in this password file. In this case, it's only one password. And I say OK. And it doesn't take very long. And I get a result here. And I get a result, which is, okay, the password I've cracked is just password. How did that work? So this tool, John the Ripper, does basically one thing. If it doesn't find a default password, is just trying every possible password, just starting with 1. Okay, it's not 1. Starting with 2. Okay, it's not 2. And testing every possible password would take very long. So to avoid this long process, it starts with trying some default passwords. For example, the password is a very common password it's also, or it was the default password for type 3 as well, for the admin user. So this tool found it very quickly. Alright, so of course if I have install tool access, I can do many things like, where this was. I think it's important actions, right? Where I can create a new, just create a new user here and then log into the backend. And with an admin user in the backend, of course, the people will many things. So basically, my website got hacked, right? Okay, so it can be that this hack isn't discovered for a longer time, but at some point it will be discovered. This is the normal process, I would say. It is discovered because, for example, you find some strange links on your website, or you find corrupted data on your website, or stuff like that. So you find some side effect which you didn't see before, right? So the website doesn't work like it should work. That's how you discover it. And the question is, if you discover something like this and you suspect a hack, what should you do? And the very first thing you should do is take the site offline. To not give the attackers additional chances to go further. And it's hard to say to your customer, but it's really important to do so. And I really mean it, and you should do it. Right? And having the site offline gives you more time and confidence to do the analysis, which is the next step. Because what you need to find out is, how did the attacker manage to get into my website, or set links up there, or corrupt anything. And before you start digging around and doing things, it is recommended that you do a backup from the state, because sometimes just by analyzing, you create a lot of new files. For example, you're looking for log files and grabbing some state out there and creating new files, and then delete something, and probably accidentally deleting some evidence or stuff like that. So a good idea is to just conserve the current state you have. And then, like I said already, what you then need to do is search all your log files you have. Most likely the Apache error log, but also other log files like FTP upload log, or PHP error log, or stuff like that, for suspicious entries. What could suspicious entries look like? I show you don't have an access log here, but I can show you the requests the SQL lab tool did in the SQL lab log. Here. So if you go to your Apache log, a request like this looks very suspicious, right? So do yourself a favor and look in your logs after the session, or I don't know, in a few days. It could be that you find something like this already in your logs. It doesn't mean that you're vulnerable, but somebody tried your website if it's vulnerable. And something like this with insert into or whatever. It's very likely that you find something like this at some point in time. And if you suspect some kind of SQL injection, like I showed you here, it's probably good to look for select from or stuff like that in your Apache log, because normally something like that is not in Apache log. But it mustn't be the case that the entry point is SQL injection or some other kind of web request on your website. It could be, for example, that not the web page itself is vulnerable, but that the laptop, which is used to upload files via FTP, has a Trojan or stuff like that, or a virus on it. So it could be that the FTP password is compromised, or that Somebody, which is also a bad idea, is in an internet cafe with an unprotected Wi-Fi and then uploads things on the website with, via FTP, because FTP, the protocol, doesn't have any encryption at all, which means if you upload via FTP over an unencrypted Wi-Fi, basically everybody else in that Wi-Fi could see your password. And this is why you probably not only should look in Apache error log, but also, for example, in FTP logs and stuff like that. So the main point of this analysis is to find out and get confidence about the entry point of the hack. So it's not important to find files like this one here. You will very likely find files like these, right? So, and these obviously, if you look at them, I can show you one. It looks like that, and it looks also very suspicious, and you can reformat the code here that you get a better impression about that. And if you analyze such files, you will find that this is, of course, some kind of tool which hackers used to do additional attacks, but it doesn't help you if you analyze these things. It is important to find out how did this thing get on my page. So that is the important thing. So it's important that you find how did these files get there? How did these artifacts get there? What is the actual security issue here? In this case, I would find, okay, obviously this argument or this parameter call pause, I can do queries with, by using that, so it's an SQL injection. But yeah, that's the main point, that you find that out. And if you have any doubts, or if you're not sure, okay, this is the entry point, this is how my website got hacked, it's probably a good idea to get help. There are a lot of security companies out there which offer such analysis. Okay, so, but if you found it out, in this case, I found out that it's obviously an SQL injection, you need to fix that. You need to fix the reason for the hack. And in this case, what was vulnerable was TypeScript. And the TypeScript I wrote enabled attackers to use any value in Corpus to execute queries basically. And to fix this, if you really want to use such dynamic TypeScript with content, you have to use this select markers feature. Have you ever heard of this feature, select markers? No? Okay, so it's basically you write your query how you want to how you want to how it should look like, but you don't use TypeScript to insert directly the value in there, but basically place a marker, and then with select markers you say, okay, the marker call pause should get its data from get post request. Then you're safe. And the same, of course, is possible in more complicated queries. It's also, of course, documented in TypeScript reference. But in general, I would recommend that you don't do such stuff at all in TypeScript. So it's fine if you have some more complicated queries to select your content or to select different content. That's absolutely fine, but you should avoid making it dynamic like this. It wouldn't work very good anyway, because this only works if your page isn't cached, which is probably also better here, that you only have uncached pages. Alright, so the fix, of course, is to close the security issue. In this case, we closed it in our TypeScript, but it could be, for example, that an extension is vulnerable, that you find out, okay, I didn't update the extension, whatever, foo, and the security team, the Type3 security team, released an advisory 2 years ago that this extension foo has an SQL injection, but it didn't update it because it was lazy. So the fix would be to update this extension. Or the same goes for core, of course, if you have some vulnerability in the core and you didn't update it, this will be the fix. And deploying the fix isn't necessarily enough, because what you then also need to do is remove all artifacts from the hackers, right? So if I would fix my TypeScript on my page, it would be great, so people, the attackers couldn't use SQL anymore to exploit, but I still have these files here. So these files, of course, also need to be removed. But where do I know, or how do I know where the attackers placed files? In this case, it's SQLmap is nice and puts it in the root directory, but it could be anywhere. It could be hidden in Type3 temp, whatever, and it's very, very common that attackers put it in Type3 temp, GB, cache, whatever, blah blah blah, .gif, .php, or stuff like that, so it kind of looks like an image or whatever. They're pretty clever in trying to hide things. Oops. Okay. So the best thing would be if you would just delete everything and restore from backup from a point in time before the attack was taken. Okay. Yeah, basically, just improvising here. So restore from backup, or if you're really confident, okay, I'm sure I removed everything, for example, by comparing timestamps of all files in your file system and saying, okay, these files created from the hackers, I'm sure they must be created at some point in time and stuff like that. Or if you have, I don't know, if you know, for example, this is a certain deployment, I know which files are in my document root, or there couldn't be other files, stuff like that, then you can create a diff, what files are there or not. But it's really hard to clean it up, so it's really the best way or the best recommendation would be just delete everything and restore from backup. And hopefully you have a backup, and hopefully it's not too old. And after that, you could go online again. So is there any chance we get the beamer running? Or just okay, so basically that's the key things I want to say. So, but what is important if you went through all this process is if you made the website if the website is online again, that you won't stop there, but it's important to learn from what happened right now. So it's important that you plan improvements for the process, so you can look back what took so long to find it out, or why didn't I have a backup from, I don't know, 2 days ago, and why did I have to take a backup which is 1 week old, or stuff like that. And yeah, you should implement some fixes, or you should learn from your failures. And one thing, of course, could be that you educate your developers, or do some security training sessions, or stuff like that. All right, so up and running, I would just show you my last slide. Yeah. Just to recap, so that's the important part after we are online again, that you plan these improvements. And as I said, you should learn from your faults. In this case, you probably would want to do some quality assurance for things, because in this case it was the security issue was just a bug, I would say, and you can avoid bugs obviously if you do some kind of quality assurance. The other mistake which was made was that I directly edited things on production. And tested things in production. Of course, you should learn from that. That it's good to have development and testing environments, which you probably have. And don't touch production except for a defined process, which is called deployment. And of course, what can be learned from that is that only provide the privileges needed to run your service. In this case, the database user should be limited. Have limited permissions, and stay focused, which is meaning that don't distract yourself, or don't get distracted, or try to not be distracted. If you're doing something, I don't know, you can in your office if you want to be, if you want to stay focused, make a sign or whatever, don't distract me, or turn off your phone or whatever. Try to stay focused, which also helps to avoid errors. And of course, if you fail, which always can happen, everything I showed you, like having a root user as for the database connection, or having debugging mode on a live production website. All these things I have seen. It's not made up. Of course, the combination is pretty made up, but everything I showed you, I just saw on live production sites. So if you fail, fix it and try to improve and try to not make the errors. And of course, especially when speaking about this cycle of improving, it's very good that you have a defined process for such incident handling and or for avoidance that something like this always happens. And so one major thing is, of course, you probably know that, is that you schedule time to do updates. So if your software you use get updates, then just also update it. That you do regular backups, that is very important. And if possible, just implement a lot of monitoring. So for example, I don't know, monitor if some important service of your website is still running, or if the content of the website has the important content shown, or stuff like that. And of course, always invest in education. And all this consumes time. You don't get this for free. Reserve time for that. So that's one thing. And the tools I used, you can find here on these URLs: SQL Map, the John the Ripper is an open wall. So the security guide is twice because it's very useful. Do you know the security guide? It's a documentation. It's really great. It's focused on integrators and system administrators, and there are a lot of tips and hints in there how you can set up your Type 3 installation in a secure way. And a great source for what kind of exploits are there, for example, SQL injection or cross-site scripting or whatever, is the wiki page OWASP.org, which is it's an acronym for Open Web Application Security Platform. So it's a great source for looking for security stuff. All right, so I think time is over, but still, do you have any questions? Yeah.
About the presentation, it is used for only testing HTML or for the other framework?
Oh, you absolutely, the SQL Web tool you can use for everything. So it's just it's completely framework or whatever agnostic. It just tries putting several things in this parameter. So if you use Drupal or WordPress or whatever, it also works if there's an SQL injection. So it just tests for this specific vulnerability, which is inserting SQL code through a get parameter. So, but that's, it's not only for Type 3, it's for everything, just for Paint, PHP scripts or WordPress or whatever.
It's not even just for PHP.
It's not even just for PHP, of course. It's not, exactly. So SQL injection is not limited to PHP. Any further questions? If not, then thank you for your attention.